Hey everyone, and welcome back to the channel. Today, we're talking about something huge. Literally, the biggest thing in our solar system, the sun. It might look like the same friendly, life-giving star it always is, but right now, it's gearing up for a period of intense activity called the solar maximum. And this time, it's coming sooner and stronger than scientists originally predicted. So, what does this mean for us here on Earth? Is the sun actually getting dangerous? Let's break it down. First, let's get a handle on what a solar cycle even is. Think of the sun as having a heartbeat, but instead of beating every second, it has an 11-year cycle. This cycle is driven by the sun's magnetic field, which gets tangled up, flips, and then untangles itself over about 11 years. At the beginning of a cycle, during what's called the solar minimum, the sun is relatively calm. It has very few sunspots, which are those darker, cooler areas on the surface. But as the cycle progresses, things get a lot more exciting. We're now heading into the peak of solar cycle 25, the solar maximum. During this time, the sun's magnetic field is at its most tangled and chaotic. This chaos manifests as a dramatic increase in sunspots. These sunspots are not just cosmetic blemishes. They are the breeding grounds for massive solar events like solar flares and coronal mass ejections, or CMEs. A solar flare is an intense burst of radiation, a flash of light and energy that can reach Earth in just minutes. A CME, on the other hand, is a colossal eruption of plasma and magnetic field from the sun's corona, its outer atmosphere. These can travel a bit slower, taking anywhere from 1 to 3 days to reach us. So, why are we talking about this now? Well, scientists at the National Oceanic and Atmospheric Administration, or NOAA, have updated their predictions. Originally, they thought solar cycle 25's maximum would be relatively weak and peak around July 2025. But the sun has been far more active than expected. The new forecast says the maximum will likely arrive sooner, between January and October of 2024. Not only is it early, but it's also expected to be much stronger than the last cycle. We're already seeing evidence of this, with a significant increase in powerful X-class flares, the most intense kind. Now for the big question. How does this affect us on Earth? We're protected by our planet's magnetic field and atmosphere, which shield us from the worst of the sun's radiation. You're not going to get a sunburn from a solar flare. The real danger isn't to our bodies directly, but to our technology. Our modern world is built on a fragile electronic backbone and a powerful geomagnetic storm caused by a CME hitting Earth's magnetic field could wreak havoc. Think about it. Satellites are the first line of defense. A blast of charged particles can damage their electronics, disrupt their orbits, and even cause them to fail completely. This impacts everything from GPS navigation, which so many of us rely on daily, to television broadcasts, and of course, our global communications network. The Starlink satellite network has already experienced this, losing dozens of satellites after a geomagnetic storm in 2022. As we launch more and more satellites, the space around Earth is getting crowded, and the risk of collisions and widespread damage during a solar storm increases. Down on the ground, the effects can be just as significant. Geomagnetic storms can induce powerful electrical currents in long conductors like power lines and pipelines. These unexpected surges can overload transformers and other critical components of our electrical grid, potentially causing widespread and long-lasting blackouts. One of the most famous examples is the 1989 Quebec blackout, where a solar storm knocked out power for 6 million people for 9 hours. And that was from a storm that was powerful, but not even close to the worst-case scenario. What is the worst-case scenario? We have to look back to 1859, to an event known as the Carrington Event. This was the most powerful geomagnetic storm ever recorded. It was so intense that telegraph systems, the high-tech of the day, shorted out, shocked their operators, and even caught fire. Auroras, the northern and southern lights, were seen as far south as Cuba and Hawaii. People in the Rocky Mountains woke up in the middle of the night, thinking it was dawn because the sky was so bright. If a Carrington-level event happened today, the consequences would be catastrophic. A report from Lloyd's of London estimated that the cost of damage could be in the trillions of dollars, and it could take years, even a decade, to fully recover. We're talking about a world without power, without the internet, without GPS, without modern banking or communications for an extended period. It would essentially send us back to a pre-industrial age overnight. It's a sobering thought, and it's why space weather prediction is becoming so important. The good news is, we're not flying completely blind. Agencies like NASA and NOAA have a fleet of satellites, like the Solar Dynamics Observatory and the Parker Solar Probe. But as the sun ramps up its activity, the challenge intensifies. More frequent and powerful storms mean we're constantly on alert. And there's always the chance of a black swan event, a storm so powerful and fast that it catches us off guard. That's why research into better prediction models and more resilient infrastructure is so critical. We need to harden our technology against the sun's fury. On a more positive and beautiful note, there is a spectacular upside to all this solar activity, the auroras. The same charged particles that threaten our technology also create the breathtaking northern and southern lights. As the solar maximum approaches, the auroras will become more frequent, more intense, and visible at much lower latitudes than usual. So if you've ever dreamed of seeing the aurora borealis or australis, the next year or two will be your best chance in over a decade. Keep an eye on space weather forecasts, because you might just get a light show in your own backyard. So to sum it up, the sun isn't turning evil, but it is entering a period of high energy and unpredictability. The upcoming solar maximum for solar cycle 25 is proving to be stronger and earlier than we thought. While it poses a significant risk to our technological infrastructure, from satellites to power grids, it's also a powerful reminder of the dynamic and interconnected nature of our solar system. Scientists are watching closely, and the world is better prepared than ever before. But it's a race against time to ensure our modern way of life can withstand the full force of a solar storm. And in the meantime, we get to enjoy some absolutely stunning auroras. What are your thoughts on the solar maximum? Are you worried about the potential impact, or are you just excited for the aurora displays? Imagine a world plunged into darkness. No internet, no phones, no electricity. It sounds like the plot of a disaster movie, right? But what if I told you this isn't science fiction? It's a real threat, one that has happened before and will happen again. We're talking about a solar storm of epic proportions, a modern-day Carrington event. Back in 1859, the most powerful solar storm ever recorded hit our planet. It was named the Carrington Event after the British astronomer Richard Carrington, who witnessed the massive solar flare that caused it. In those days, the most advanced technology was the telegraph system. When the storm hit, telegraph wires burst into flames. Operators got electric shocks, and some systems continued to work even after being disconnected from their power sources, running on the sheer electrical energy from the sky. The northern lights, usually a spectacle for the poles, were seen as far south as Cuba and Hawaii. Now fast forward to today. Our world is a delicate web of technology, completely dependent on electricity and interconnected systems. So, what would happen if a Carrington-level storm hit us now? The consequences would be catastrophic, far beyond just a few fried telegraphs. First, let's understand what a solar storm is. Our sun is a giant ball of hot, electrically charged gas. Sometimes it releases huge bursts of energy and particles into space. These are called coronal mass ejections, or CMEs. Most of the time, they miss Earth completely. But if a powerful CME is aimed directly at us, it can wreak havoc on our planet's magnetic field. This interaction induces massive electrical currents in long conductors on the ground. In 1859, those conductors were telegraph wires. Today, They are the high-voltage power lines that form the backbone of our global electrical grid. A Carrington-level storm would induce currents so powerful they would overwhelm and destroy the giant transformers that are the heart of our power grid. These transformers are not something you can just pick up at the local hardware store. They are custom-built, weigh hundreds of tons, and can take months or even years to manufacture and install. If hundreds of these transformers were to fail simultaneously across a continent, we'd be looking at a widespread, long-term blackout. We're not talking hours or days. We're talking weeks, months, or in the worst-case scenarios, even years. Let's walk through the domino effect. The moment the power goes out, our modern lives grind to a halt. Your lights go off, your Wi-Fi dies, and your fridge stops humming. Initially, you might think it's just a normal power outage, but soon you'd realize your cell phone has no signal. Cell towers need electricity. The backup generators they have would only last for a day or two. No calls, no texts, no internet. Communication systems would be among the first to go. Without the internet, the global financial system would freeze. Stock markets, bank transfers, credit card transactions, all of it would cease. ATMs would be useless. The cash in your wallet would be all you have, and soon it might not be worth much as society struggles to function. Next, consider our water and sanitation systems. They rely on electric pumps to move water to our homes and to treat sewage. Without power, clean water would stop flowing from our taps. This isn't just an inconvenience. It's a major public health crisis waiting to happen. Contaminated water sources could lead to outbreaks of diseases like cholera and dysentery. Then there's our food supply chain. Modern agriculture is heavily dependent on technology, from GPS-guided tractors to refrigerated storage and transport. A massive blackout would paralyze it. Farms couldn't operate, food couldn't be shipped, and grocery stores would be unable to preserve what little they have. Shelves would empty out in a matter of days. Hospitals would face an unimaginable crisis. They have backup generators, but these are designed to last for a few days, not months. They would quickly have to make heartbreaking decisions about who gets access to life-saving equipment. Essential medical supplies, which are managed through just-in-time delivery systems, would stop arriving. Transportation would be a nightmare. Gas stations need electricity to pump fuel. Electric vehicles would be useless. Even gasoline cars would eventually run out of fuel. Roads would be gridlocked as traffic lights fail, and people attempt to flee cities in a panic. Air travel would be grounded indefinitely. And let's not forget our satellites. The intense radiation from a massive solar storm could damage or destroy the sensitive electronics on board our satellites. This means no GPS, no satellite TV, and no weather forecasting. GPS is more than just a map on your phone. It's crucial for timing and synchronization across countless systems, including the financial network and power grids themselves. Losing it would add another layer of chaos to an already dire situation. So, how likely is this? Scientists at NASA and NOAA are constantly monitoring the sun. They can give us some warning, typically 12 to 48 hours before a CME hits Earth. But a Carrington-level event is a question of when, not if. Studies estimate the probability of such an event happening in any given decade is around 12%. That's a higher chance than you might think. We've had close calls before. In 2012, a Carrington-class CME erupted from the sun and crossed Earth's orbit. Fortunately, Earth had passed that point in its orbit just a week earlier. We dodged a cosmic bullet. Another, less severe storm in 1989 knocked out the power grid in Quebec, Canada, leaving 6 million people in the dark for 9 hours. That was from a storm much weaker than the Carrington Event. So what can we do? The good news is, we are not completely helpless. Governments and power companies are aware of the threat. There are efforts underway to harden the grid. This includes developing better forecasting models, creating strategies to power down sensitive parts of the grid before a storm hits, and stockpiling spare transformers. But progress is slow, and the cost is enormous. On a personal level, preparation is key. Having an emergency kit is a good start. This should include non-perishable food, a method to purify water, flashlights, batteries, a first aid kit, and a battery-powered or hand-crank radio to receive emergency broadcasts. Having some cash on hand is also a wise idea. Think about it like preparing for a hurricane or an earthquake, but on a much larger and longer scale. The Carrington Event isn't a doomsday fantasy. It's a real natural hazard that our technology-dependent civilization is uniquely vulnerable to. While the scenario is frightening, understanding the risk is the first step toward mitigating it. It's a reminder that for all our technological prowess, we are still at the mercy of the powerful forces of our own star. The lights could go out, and we need to be ready. Imagine waking up one morning. You reach for your phone, but there's no signal. Not just your phone, but nothing. No internet, no GPS, no TV. The world has gone silent. What's happened? It's not a power outage. It's something far more cosmic. A solar superstorm has hit Earth, and our entire satellite network is down. This isn't science fiction. It's a real, albeit rare, possibility. So, what would happen in the first 72 hours? And how would we, as a civilization, cope? Let's dive in. First, let's understand what we're up against. A solar superstorm, or a severe geomagnetic storm, happens when the sun ejects a massive burst of energy and plasma, known as a coronal mass ejection, or CME. If a powerful CME is aimed directly at Earth, it can wreak havoc on our magnetosphere. The most famous example is the Carrington Event of 1859. Back then, it fried telegraph systems worldwide. Imagine what an event of that magnitude would do today to a world utterly dependent on fragile electronics and satellites. So the storm hits, hour one. The first and most immediate effect is the loss of our satellite infrastructure. This means 3 critical systems vanish instantly: communication, navigation, and timing. Your smartphone becomes a glorified paperweight for anything requiring a network. You can't make calls, send texts, or scroll through social media. The global flow of information stops dead. News outlets would struggle to broadcast, and governments would find it incredibly difficult to issue public announcements. We'd be plunged into an information blackout, relying on old-school methods like local radio, if the ground stations are still operational, or simply word of mouth. With GPS gone, navigation as we know it disappears. Think about it. It's not just your car sat-nav. Global shipping, aviation, and even ride-sharing services all depend on the global positioning system. Without it, planes would be grounded. International flights would be an immediate impossibility due to the reliance on satellite communication and navigation over oceans. Ships at sea would have to revert to celestial navigation and traditional charts, skills that are becoming rarer. The intricate dance of global logistics, which brings food to our stores and packages to our doors, would grind to a halt. Supermarket shelves would start to empty much faster than you think. Then there's the third pillar: timing. This is the invisible utility provided by satellites that most people don't even know about. The precise time signals from GPS satellites are essential for synchronizing everything from financial markets to power grids and cellular networks. The New York Stock Exchange, for example, relies on this synchronization for high-frequency trading. Without it, the global financial system could face chaos, potentially freezing transactions and causing a worldwide economic panic. Power grids, which also use satellite timing to balance loads, could become unstable, leading to widespread blackouts that could last for days or even weeks. So, not only are we in the dark information-wise, we might literally be in the dark too. Let's move into the first 24 hours. Panic hasn't fully set in yet, but confusion is rampant. People are trying to figure out what's going on. Without news, Rumors would spread like wildfire. Is it a cyber attack? An act of war? An alien invasion? The lack of clear information is a crisis in itself. Communities would start to look inward. Neighbors would talk to neighbors, sharing what little information they have. Local emergency services, police, fire, and medical would be stretched to their absolute limits. Their communication systems, often reliant on satellites, would be compromised, forcing them to use short-range radios and runners to coordinate. Getting help in an emergency would become a serious challenge. Hospitals would face a critical situation. Modern medicine is deeply intertwined with technology. Patient records, diagnostic equipment, and communication between departments all rely on network systems. While they have backup generators for power, the loss of network connectivity and satellite-dependent equipment would be a massive blow. Accessing patient histories or consulting with specialists in other locations would become impossible. The supply chain for medicine and medical equipment would also be broken. By hour 48, the reality of the situation would be sinking in. The initial novelty and confusion would give way to genuine concern. Food and water would become the primary focus. People would rush to stores, and with supply chains broken, panic buying would empty shelves within hours. Those without a decent supply of non-perishable food and water at home would be in a vulnerable position. Access to cash would be another major issue. ATMs wouldn't work, and credit card transactions would be impossible. The world would revert to a cash-based or even a barter-based economy overnight. If you didn't have physical cash on hand, you'd have a real problem. This is where human ingenuity and community spirit would truly be tested. We'd see a return to older ways of doing things. Amateur radio operators, or hams, would suddenly become vital communication hubs, relaying messages and news across vast distances, bypassing the dead satellite networks. People would dust off old paper maps to find their way around. Communities would organize, setting up neighborhood watches and sharing resources. We'd see the best of humanity, with people helping each other, but also potentially the worst, as desperation could lead to conflict over scarce resources. Now we reach hour 72, 3 days in. Engineers and scientists around the world would be working frantically to assess the damage and begin repairs. The good news is that many satellites are designed with protections against solar radiation. They can be put into a safe mode to ride out the storm. The process of rebooting the global satellite network would be complex and time-consuming. It wouldn't be like flipping a switch. Each satellite would need to be checked, reoriented, and brought back online one by one. Priority would be given to critical services. First, military and government communication, then GPS for transport and finance, and finally, public communications and entertainment. We might start to see a flicker of a signal returning. A single bar on your phone, a GPS lock that holds for a few seconds. These would be the first signs of recovery. But the world would be changed. This 72-hour blackout would serve as a colossal wake-up call. It would expose the shocking fragility of our high-tech civilization. We have seen how quickly our modern world can unravel when one key piece of technology is removed. The economic cost would be astronomical, running into the trillions of dollars. But the social cost would be even greater. So, how can we prepare? On a governmental level, it means investing in hardening our infrastructure. This includes building more resilient satellites, creating better space weather prediction models, and developing backup systems that don't rely on space-based assets. Think of ground-based navigation systems like ELORAN, a modernized version of a World War II-era system. On a personal level, it's about basic preparedness. The same advice for any natural disaster applies here. Have a family emergency plan. Keep a stock of non-perishable food, water, and any necessary medications to last at least 3 days, if not more. Have a battery-powered or hand-crank radio for information, and keep some cash at home. It's not about being a doomsday prepper. It's about being a responsible citizen. A solar superstorm is a low-probability, high-impact event. It might not happen in our lifetime, but it could happen next year. The 72 hours without satellites would be a profound challenge, pushing our society to its limits. But it would also be a powerful reminder of our resilience, our ability to adapt, and the importance of community. It would force us to reconnect with the physical world and with each other in a way that our digital lives often prevent. We would survive, and we would rebuild, hopefully with a newfound respect for the invisible technological web that holds our world together and a better plan to protect it.